1906, a 7.8 magnitude earthquake hit San Francisco. Fires burned for 4 days, 25,000 buildings were destroyed, and an estimated 3,000 lives were lost. The stage for that disaster was set 20 million years ago, when two tectonic plates came together to form the San Andreas Fault, an 800-mile-long network of earthquake-causing cracks in California. In fact, we're in one right now. But the question is, when's the next big one? I'm Jake, and this is Extreme Science. Let's imagine that the surface of the Earth is an eggshell. Well, to be more precise, a broken eggshell, where all these little pieces are the surface, the tectonic plates. And they are always shifting and moving, about 34 meters every 1,000 years. When they stop moving, tension builds up, like stretching a rubber band, until it finally snaps. All of that energy being released moves through the Earth, creating an earthquake. It is estimated that 12,000 to 14,000 earthquakes happen every year, about 35 a day. A little over 1,000 of them are ever large enough to cause any structural damage. Where we are now on the fault line, the plates have collided, literally pushing the Earth out of the ground. And in North America, when we think about earthquakes, we tend to think of California. There was a movie recently called San Andreas about a magnitude 9 earthquake destroying a large portion of the state. But we've experienced one on that scale before, in a place where 9 out of 10 of the largest earthquakes in US history have occurred, 3,500 miles away in Alaska. The 1964 Alaska earthquake was the biggest in recorded US history, coming in at 9.2 on the Richter scale. Some areas were raised 30 feet, others dropped 8 feet into the ground. Tsunamis went as far as Hawaii and Japan, and effects from the quake were felt all the way in Texas. Now, to put into perspective just how powerful a magnitude 9 would be, let's go down the logarithmic Richter scale to a 2. At 2, we would hardly feel it. At 6, it would be equal to 120 million pounds of TNT. Pretty powerful. At 8, we get to the 1906 San Francisco quake. Its energy equivalent is close to the volcanic eruption of Mount St. Helens. At 9, we have the Alaska earthquake, 4 trillion pounds of TNT. The most powerful one we've ever experienced was in Chile in 1960, coming in at 9.5. In 2004, scientists dug 2 miles underneath the San Andreas fault line and discovered some very curious things. For example, the first samples they brought up were literally boiling hot. They also observed the smallest earthquakes ever recorded. So small, in fact, that they had negative magnitudes. When the Richter scale was created, 0 was assigned to the smallest earthquakes measurable at the time. If we go to, say, negative 0.2, the energy equivalent would be that of 30 matches being lit. Pretty tiny comparatively, and we wouldn't even feel it. But scientists can measure it. As it turns out, we can measure earthquakes that don't even happen on Earth. In the 60s and 70s, Apollo astronauts put seismometers on the moon, which revealed quakes of up to 5.5 on the Richter scale, and they lasted for 10 minutes. On Earth, quakes generally dissipate much more quickly. That's because unlike our natural satellite, the Earth has water and it absorbs vibrations, deadening them. And as you can see around me, it looks pretty lush. And that's because along the fault line, shear zones are created, and through them, water reaches the surface, creating an oasis. The fault line just doesn't run through the desert. It runs through cities and towns, like this one. And the damage it would cause would be catastrophic. The Southern California Earthquake Center made a simulation of what an M8 earthquake would look like on the San Andreas Fault. The U.S. Geological Survey created their own video of a realistic look at the effects of a 7.8 magnitude quake, injuring 53,000 and costing around $213 billion. So what do we do to stop it? Well, that's the scary thing about earthquakes. We can't. Generally, we don't even know when they're going to happen. The last big one occurred in California in 1857, and according to scientists, it happens every 150 years. But it's already been 158. What everyone says is to be prepared. The SCEC started the Shakeout program, which instructs you to drop, cover, and hold on. The ground beneath us is constantly moving, constantly changing, creeping and locking. All we can do is move along with it and try to hold on. I'm Jake, and this is Extreme Science.